Welcome. This is a focused revision explainer on redshift, which is a really key topic in your GCSE space physics paper. Okay, let's just dive right into it.
We're going to break this down into 4 clear sections. This will give you pretty much everything you need to know for your exam.
So, first up, we've got to get our heads around the fundamental observation that really underpins so much of modern cosmology. I mean, it's a huge question, right? Astronomers obviously can't just go out there with a giant tape measure. So instead, they have to look for clues, and those clues are hidden in the light from distant stars and galaxies.
And this is the central clue, redshift. Think of it like the sound of an ambulance siren. As it moves away from you, the sound waves kind of stretch out and the pitch drops, right? Well, it's the same idea for light. As a galaxy moves away from us, the light waves it's emitting get stretched, and that shift moves them towards the red end of the spectrum.
Now, here's the crucial part, and it's a bit of a mind bender. It's the expansion of space itself that causes the stretching of light. It's not just that galaxies are flying through space away from us. The actual fabric of space between us and them is expanding, and that's what's stretching out the light waves.
Okay, let's move on and see how this all builds up. What does this redshift observation actually tell us about our universe?
This simple relationship is honestly one of the most important discoveries in the history of astronomy. It is the key piece of evidence. The pattern is just crystal clear. The more distant a galaxy is, the more its light is redshifted. Now, what's really great about this slide is that these 4 points, they are exactly what you need to remember for your exam questions on this topic. Seriously, if you can walk through this logic, you've totally nailed it. So, if we know the universe is expanding and everything's moving away from everything else, well, we can ask a really logical next question. Where did it all come from? Yeah, running the film backwards leads to just one single inevitable conclusion. If everything is moving apart now, then way back in the past, it must have all been much, much closer together. It must have all started from one place. And that right there is the Big Bang theory. The evidence from redshift, the evidence of an expanding universe, is the main reason why the Big Bang model is the most widely accepted theory for the origin of the universe. The evidence supports the theory. But science never stops, and the story of the universe is far, far from complete. Let's take a quick look at the huge questions that scientists are still working on today. For decades, scientists actually debated whether the expansion was slowing down. I mean, it makes sense, right? Gravity should be pulling everything back together. But then, in 1998, a new discovery completely changed everything. And this is a brilliant illustration of how science works. New evidence can totally change scientific theories. It turns out the universe isn't just expanding. Its expansion is actually accelerating. It's speeding up. So this leaves us with these 2 massive, unanswered questions in physics today. What is this mysterious dark energy that's putting its foot on the accelerator? And what on earth is the unseen dark matter that seems to be holding galaxies together? It just goes to show there is still so much left to discover about our universe.